Alright, welcome to Breaking Boundaries, your whole house is now a game. So, my name is Clement. I'm from France. I'm actually a French-American. Here's a bunch of stuff I like, including cats. And this is a silly picture of me wearing spectacles from Snapchat. Some background about myself. I actually started my career at Apple, working on SpriteKit, and did some animation. So if you ever sent Happy New Year to someone on an iPhone and you saw fireworks, that was me. I'm so sorry if your battery is dead now. And then, more interestingly, I got to join the VisionOS project pretty early on. It was pretty cool. And that was kind of my real start in XR, so roughly 10 years ago now. After that, I went to Meta to work on the Meta Quest 2, do some of the remote rendering projects, and also worked on Workroom, which is a collaboration app in VR. Led the team that built Effectas, which is basically an AR effect creation tool for mobile. And more recently, founded Subjective Experience Studio, which is just an indie studio making some cool little apps on VisionOS, including ShaderVision, which is a GPU shader editor. Pulsargeist, we're going to talk about that soon, and some consulting, for example, Sidekick, which is a little avatar for special computing. Cool. So let's talk about Pulsargeist. Here we go. So Pulsargeist is a game that is pretty scary, but no worries, there's no jump scare today, you're not going to be scared. So imagine that you could play a horror game in your house. You're just chilling in your place, and then out of nowhere now there's people coming at you, you're in the dark, it's very scary, and you have to survive. So that was the idea that was developed in 48 hours for a hackathon. I'm just going to play the trailer for you guys to see how it looks like. Cool. So, what did this talk about? It's about... So this talk actually is about breaking boundaries, which is a super exciting thing with the new latest generation headsets such as Vision Pro. And so what do I mean by breaking boundaries? I mean basically extending the boundaries from just a single room to multiple room and what I call multi-room scale experiences. So we'll talk about what kind of things exist today, there's not too many yet, and then how do we build them? Some of the design principle for designing this kind of app, and then as a case study we'll look into my learning for Pulsargeist, how did I do it, some of the things to do and not to do. So first, some history. Who doesn't like history? So how did we get there? So it all started with some headset that had, what we call 3 degrees of freedom. So it's pretty much very limited. You can move your head, up and down like this. It works. It's pretty cool. But there's a dimension missing here, and this is where the first breakthrough came with 6 degrees of freedom, which allows you now to move around and experience the world, in your surroundings. So pretty cool stuff. The way it used to work was with something called outside-in tracking, where we basically had these cameras that were kind of fixed in space, and they would track you, send the data back to the headset to know your position in space. But it would be kind of annoying to set up, and it would pretty much constrain you to a given area. Then another breakthrough came through with inside-out tracking, where we move the camera inside of the headset, allowing you to just put the thing on, and it just works. It's really awesome. This made VR at the time much more accessible and much more interesting as well, because you can just work around. It just works. Pretty magical. With that being said, there was still progress to be made, and so initially most of the experiences required you to have these virtual boundaries around where you are. Usually it was called a guardian, and you would see this kind of fence around you that tells you like, don't step there, or you're just gonna have some issues. So we're still constrained the space, which is, it's better, but we can do even better. And this is to where we are now with live environment understanding. So now we can actually have the headset understand the context of your surrounding and get some cool stuff, like for example, mesh reconstruction, where you can have an actual physical thing represented in 3D with a mesh. So what are people building? So I showed you my app, which is cool, but let's see what other stuff is happening. Just a quick disclaimer, the stuff I'm going to show is not always on Vision Pro, but it could perfectly be on Vision Pro as well. So pretty classic is these shooter games where you start to shoot around and then your apartment, whatever, starts to break, and there's like this whole world behind you and you have to survive. So it's cool. I saw a lot of these though, so if you like shooter, it's cool, but if you want something more creative, more interesting, I think we can do better. So another one I really like is Starship Home. So this basically takes your home and transforms it into a spaceship. So you get to kind of do the maintenance, you get to do the navigation, explore space, new environment, super fun stuff. You also get to customize, your space with some flowers, with some little maintenance on making sure they're watered, fix the leaks in the ceiling. Pretty creative. A bit more silly, but we have this, who doesn't like to vacuum, right? So with this experience on Vision Pro, actually, you can gamify, the chore and get some points as you vacuum your apartment. Okay, so this one is a proof of concept. It's not real. It was done by Jesser 722. It's called LightSkin. This is kind of to give you an idea of what we could get in the future with Gen AI and all the kind of cool stuff we have currently in AI. Just to clarify, this was done in October 2024, and it takes a minute to generate 10 seconds of footage here, and it's only 720p, which is pretty far from the 4K we need per eye for Vision Pro. So I think in the meantime, until we get this kind of thing where, again, we can teleport into a different environment, different mood, until we get there, I think we'll get some stuff like, for example, procedural mesh, where you can transform your environment into a 3D mesh and kind of adapt for different layouts and stuff like that. But this is pretty exciting. Cool, so this looks good, right? But how do we build it? If you're already a VisionOS developer, I think there's no surprise here. We'll be using ARKit. ARKit gives you, of course, all kind of tracking for the body, for the hands, objects, environment, planes, whatnot. However, if you do use ARKit, you have to make an app that's going to be a full space. It doesn't work at this time with shared space, so you will have to do immersive space. And for rendering, the usual culprit, Reality Kit. If you're feeling adventurous, you can go with Metal and Composer Services, and of course, Unity, Unreal, which I'm not going to talk too much about. So just to go a bit deeper on the boundary stuff, so ARKit, of course, has plane tracking, so you can kind of specify, like what you're looking for, like is it, horizontal, vertical, tilted. You can specify the classification. I want a table, I want the ceiling, the walls, and so, like, oh, what's the boundary that I need? So if you need a big table, maybe like a 0.5 square meter table, you can specify that. With ARKit, as of last year, VisionOS 2, we can do room tracking. So this API is kind of a helper to do a lot of stuff for you, to basically, group the anchor for a given room. It would also tell you, like, which room the user is in, which is kind of handy. However, there's some little caveat. For example, if you're in a room and then leave to go to another room, the previous room will not get updated. It's not guaranteed, so you may have to cache, like the anchors, the mesh, whatever you need for your experience. And then, as I mentioned earlier, pretty exciting is the scenery construction. So now we can get this high-resolution mesh of the environment, and you can also do classification. So actually, on this video here, you can see the couch has a different color, the floor has a different color, so you can kind of get this information from the mesh. However, you have to know that the moment you start to process your mesh, it's going to be pretty high compute because you need to, it's like a lot of data on vertices. You might need to use a background task or do something like not in real time, like every 10 frames or something. But pretty cool for like building physics or occluder, which I'll talk about later. Cool. So, okay, we got the building blocks for the code. What about the dev tools? So I just have a word about that. It's getting there. It's not great, but we're getting there. So what's the limitation? So of course we have, as you know, Reality Composer Pro, which is, in my opinion, pretty good for simple, app workflow. You want to put some content, customize the look and feel, the physics. You can also do some anchoring stuff as well. You can say, hey, this has to go on the head, on the hand, somewhere in the world, on the plane. You can specify what plane. So it is still kind of useful. ARKit does not work currently in the simulator, which is a big issue. Hopefully Apple will address this at some time. But you can do basic stuff like gaze and hand gestures. And just a quick word on Unity. They do have fully spatial and the XR simulator, which is pretty much helping what's missing with not having ARKits in the simulator. So we'll do stuff like like planes and environment mesh, but it will never replace, at this time at least, testing on device to get the actual data. All right, so your goal as a developer is to iterate fast. The faster you iterate, the better your app will be, because you can really quickly make some change, polish it, and also your dev experience is much better if you can go fast. So some tips and tricks to do that. I think this is kind of two routes. You can either go on the simulator, so stay on the Mac, and just try to be there as much as possible, because you get the fastest, like if you have to recompile, build and run, because you're on the Mac, you don't have to send the project to the Vision Pro. So ideally, that's pretty fast. And then of course, you can architecture code to handle state changes, to adjust things very quickly, jump to a different scene very quickly, so you can just quickly try things. Because you do not have access to the data from ARKit in the simulator, one trick which is pretty common is to either just fake it, just put some dummy planes, dummy mesh to simulate your environment, or you can also, if you want to go crazy, you can record from the device and then transfer back to the Mac and just use it offline to do some testing. This is spatial computing, so you can also have a window, like this one right there, which I use in my game. This window only shows up if you're doing development, and it has all kind of cool information about the game. I can quickly, press some buttons, do some stuff to switch to a different scene. And so I think there was two things. There was the Mac, or the other one, which is to be in the headset. So imagine just put the headset on, and you never have to take it, because you just do a virtual desktop. You code in the headset on your Mac. You can also code in your debug window. The bottom section here, this little black text editor, is actually a shader editor. So you can change the code of the shader, and it will just reload immediately, which is super cool, again, for fast iteration. And there's also some other ways to do this for SwiftUI, for hot reloading and things like that. But I'm not going to go into details of that. Cool, let's talk about some of the design principles for multi-room scale applications. So we're kind of redefining boundaries, and this is kind of a callback to the talk from Ryan yesterday, who made Black Box. So we're no longer constrained to a small box now. We can actually go beyond this. And the boundaries are no longer virtual, it's actually physical boundaries, so it's pretty cool. XR is a lot about giving superpowers to your users. You can fly, you can teleport, you can see through walls, all kind of cool stuff. But now we can give superpowers to your environment. And something pretty special too is now, because we have a bigger space, a different location means actually a different experience. So imagine playing a game, at your place, and you know how to dodge the enemies, what to do, and then you go to a friend's place. It's a completely different experience. So it adds a lot of replayability for your application, which is pretty exciting too. But of course, with all that freedom comes some drawbacks. And now we're increasing the complexity of literally the space. So one common way to do this as an engineer is to reduce your problem space. So what you can do is define the building blocks of your app. So what do I need? I need some rooms, I need some planes, I need some objects, okay. Then also, what is your app intent? What am I trying to build here? Is this going to be played in in an apartment? Is it going to be played in an office? If it's an apartment, maybe there'll be a bedroom, a bathroom. Okay, so I can kind of anticipate that. If it's an office, it's going to be all these different chairs and meeting rooms, so again, a bit different. And then you can also define more constraints. So for example, you could say, okay, my app is only going to be on one floor, or maybe I just need 5 rooms and I'm done, and you can just do whatever. So this is a meme you might have seen on Douyin and TikTok. It's the guy who has the smallest apartment, and he's always trying to make them better. So the point here is to talk about inclusive design, and what I mean by that is, can we make your app actually pretty cool on, in a small space? Maybe someone who has a studio, or like this guy who points 96 square meter apartments. Can you adjust the gameplay? Can you adjust, the experience? And the flip side, if your space is super big, your user might have to walk a lot or get lost, so you have to think about, okay, how can I make sure my app is going to be successful in a bigger space as well? Including outdoors, which is going to be probably a thing more and more in the future. The onboarding is super, super important because it's going to be one of the biggest friction points for the user, and that's the most important to get, again, the building blocks for your app. So it should be super clear what you have to do, no friction, because the more friction, the more you drop users. And in my opinion, a good onboarding is like a good magic trick. Again, you put the headset on, you just follow some instructions, some stories, some guide, and next thing you know, it just works. That's really magical. So try to aim for something like that just works. So capturing the environment is going to be, like I said, like a pretty expensive thing. You have to walk around, ask the user to do a bunch of things, find planes, find objects. So ideally, you can just do it one time. But in practice, the environment might change. So obviously, the walls are probably not going to change, but maybe a chair is going to move, a door is going to open. And just to illustrate that, this is actually a chair right there with the 3D mesh representation of the chair. And just to show you what happens if I move the chair. Yeah, so it's kind of weird, right? The chair slowly moves as the mesh gets reconstructed. But if your app or your game needs to know that, you should basically think about, okay, I'm going to capture the big stuff first, and then maybe run like in the background a little capture, low frequency to know what is changing, to make sure that things stay consistent and safe. All right, so the last part of this talk is going to be about Pulsargeist, so the horror game in your house. So the key design role for that game was to play in the dark, which is kind of funny for Vision Pro because it's all about all the pixels, and I literally just get rid of all the pixels to show dots. So we play in the dark. We want, of course, a very low friction onboarding, which means we're going to have to go all across the apartment, and it's pretty annoying to do that. So let's do it one time. Because each space is going to be different, and so because it's fun to have a different experience, we'll do procedural level generation. So basically, each game will be different. With some rules, of course, of game design to make sure we can gauge the difficulty, kind of anticipate enemy waves and stuff like that. Super important for a horror game, the immersion should be really, really good. You're stepping into this horror experience. You should be scared. You should be kind of hesitating to do things. And that's why I'm a big believer, again, in just things that just work. So put the headset on, use your hands, nothing else, no game controller or whatsoever. So hands only, yours. So the onboarding is, again, focusing on capturing the boundaries. We do it only one time per session, and by session I mean when you launch the app. There's a voice that guides the player, kind of like Portal, the game, like the robot talking to you. And it also teaches you about the clapping mechanic. And the little trick I do is I also place the text lower, so I can focus on capturing high quality data for the floor and the walls. Yeah, so it's the onboarding. Yeah, not super good looking, but we're going to work on that. Okay, skip. So I talked about the procedural gameplay. One thing I do here is I try to evaluate the play area. So the first way to do this was to kind of gauge how many walls we have. And my estimation was okay, if we have at least 5 walls, we can play the game. 8 is pretty good, and 12 is excellent. And based on this, qualifiers, is it small, good, excellent? we can adjust the gameplay. So for example, if you're in a very small space like the studio, you don't want to be making the enemies go too fast because they will literally just like do one step and then kill you. You also want to put the collectibles a bit further away so you can make the player move around. But on the opposite side, if you have a big space, you can make the enemies a bit faster because they can just like walk anywhere and escape from there. And the objects going to spawn are not going to be too far from each other because otherwise that's sort of a chore. You're just going to be walking all day to get stuff. It's not fun. And because we're in the dark, the space is constrained to one floor. We do not want steps, stairs, that's a recipe for disaster. Okay, so my first approach for building the level generation was to use the room tracking API, which I talked about earlier. So we were basically looking for walls. And my idea was like, okay, we'll find the walls and then pick the center of the wall as the place to place the collectible, roughly like a meter or something above the floor. And we'll just spawn the enemies based on like the location of the player, the collectibles, and make something kind of smart. So it would look like this. We would find, for example, here, this is a pretty big apartment, in my opinion, like a two-bedroom, two-bathroom kind of place. And in this scenario, the player is like, okay, I'm gonna play in my bedroom, and then my living room, the kitchen. And so in my head, I was like, okay, it's gonna look like this. I'm gonna spawn some little dots here, some sphere here and there. Should be fine, right? But then, I made the game playable, and I got some feedback from people. Hey, it's pretty cool, but unfortunately, one of the collectible is in the wall, and I can't finish the game. And I was like, okay, that's pretty bad. Talk to that guy. I was like, what's going on? Tell me. And he was like, here's what I have. I have a bookshelf, and turns out the wall is behind the bookshelf. So you end up having your collectible literally inside the bookshelf, which can be either impossible to find or physically impossible to capture. Someone else was like, hey, the collectible is on my balcony, and I don't really feel like going on the balcony in the dark. And I was like, yeah, that's fair. So, expectation versus reality, this is what I thought we would get. But in reality, it was more something like this. So for example, in the bedroom, well, no surprise, there's a bed. So now my collectible is above the bed, so I have to kind of struggle to get it. Not cool. As I walk towards the blue area, maybe the door of the bathroom is open. And then next thing you know, there's a wall there, and what's going to be happening? There will be a collectible in the toilet. Not great. Like I mentioned, you could have a laundry, a bookcase, or whatever, which has this kind of, like the wall basically is behind the furniture, so now you cannot collect your thing. Maybe you have a kitchen and there's like some dangerous knives and plates or whatever, and you're gonna destroy everything, so do not spawn stuff there. And like I said, the balcony is also like a pretty badish case. So the new algorithm was to basically go back to something a bit more high precision. So I used the scene reconstruction. So we take the mesh and we translate the mesh into a 3D grid. And from there we can kind of map the floor and also figure out with some heuristics what is walkable or not. So basically where can the player actually step. And then we just use a different algorithm to evenly distribute the collectibles on the walkable path and try to kind of do something that makes sense from a game design perspective. So now we went from this to something like that. So we still have the two rooms, but now we're actually mapping much better the walkable space, and our collectibles are actually much easier to capture. That being said, there are still some edge cases which may or may not concern you based on your app, but for me again, it was playing in the dark, so you have to think about that. The scene reconstruction algorithm doesn't capture small things, for example, a cable just dangling there, which is again perfect for falling. Or on the right here, there's a plant. So you'll be like, well, why is the plant a problem? Well, again, imagine you're walking in the dark and something touches you and you're like, whoa, what is that? So yeah, not good. Another just pretty generic issue is mirrors. Mirrors are very difficult in XR for many, many, many reasons. One of them being tracking. So what actually happens here with the LiDAR and the way it works is project some lights and then try to find them on the projectable light on the wall or whatever. So this doesn't work super well when you have something reflecting the lights, or like the glass here going through the glass. And so you end up having this virtual parallel world where like the game thinks you can step into the mirror and go into a different direction. So the way you can solve this is again, like your heuristic is going to be like, okay, my player never stepped there, so most likely this is not a real location. But still pretty difficult to handle. I talked about immersion. So immersion breakers. So it's a bit hard to see, sorry, but like in visionOS, for your safety, if you walk a bit too fast, there will be this little halo of light under your feet. Initially, I thought this was going to be a problem for my game because I want to stay in the dark. And I actually was like, okay, well, make the enemy go faster if I go too fast. But it turned out to actually be a pretty useful thing because end of the day, you still need to clap your hands to find where things are, and you need to look up to find the collectibles. So looking down is actually a good thing in terms of safety. If you get too close to a wall, you'll get the pass-through, you'll get a pop-up saying like, hey, watch out, you're gonna knock your head on the wall. If you have any living creature, like a human being or a cat, whatever, they will also show up in the pass-through. I want to mention that actually these things can be changed in the settings, which works okay for if you do a B2B application where you control the whole experience. But if you're doing a consumer app like a game, you're not going to tell your user, hey, let's go to settings and change these like dangerous settings. No, it's not going to work. So you have to kind of think about that. Something people don't know about, I saw this so many times in applications. So if you know, on visionOS, if you look at your hand, if you flip your hand like this, it will show the control center menu, which can be a problem because if your game uses hands for UX, you can accidentally launch the control center and then leave your app and it just sucks. There's a way actually to disable that. It's this bottom thing right there, the persistent system overlay. You can set to hidden. And then when you look at your hand, you will no longer get that little thing unless you really look at your hand and pinch. So I highly recommend you guys to do this if you have like a very immersive game or something using hands. It makes a huge difference. Cool. A quick word about rendering for the graphics nerds in the crowd. So this is roughly like how a frame looks like. We render the particle effects and the collectibles as well as the enemies. This is from Xcode. This is a GPU frame capture. If you know what that is, it's like one of the debugging thing you can do. So the rendering pipeline is pretty simple. It's an occluder pass. I'm going to talk about what that is very soon. The sonar pass, which is pretty much rendering the environment, particles, and then the collectible, the enemies, and then finally on top of everything, the text, so the UI pass. So pretty simple pipeline. So what's an occluder, you ask? So let me explain the best I can. So at the bottom right here, you can see an example of what I mean. So when you mix virtual content with actual real content, for example, like a table, the floor, whatever, if you don't do anything, the virtual content will be on top, which is just not looking great, right? It just looks like it's like a ghost floating around. So a technique you can do is to render what you call an occluder. So you take again that mesh of the environment and then render it as a mask for your virtual content. So then, you render that first, the table, and then after that you render your virtual content, and it will nicely look like it's behind the table, which is super realistic. Here's how you do it in XReality.Kit. It's actually not too hard. You get the mesh anchor and you generate a shape from it. And again, like I said earlier, it's going to be very expensive. So do this as a task with low priority. And then you can make a model component and give it a occlusion material. If you're doing this with metal, like I did here, you would have to do, for example, a first pass where you just write your environment mesh to the depth buffer. And then in the second pass, which is the super pass here, you would load your depth map as get the mask, and it will automatically work as intended. So not very high resolution, sorry, but this is how a frame looks like when you go through each of the draw calls one by one. You'll see the environment occluder first, and then the special effect, environment particles next. So it looks like this. Just going to go down the draw calls. And this is the environment, piece by piece. With the depth map, and then next thing you know, you do the environment properly with the walls, the tables, whatever, properly opening your particles. Cool, so closing thoughts. Again, spatial computing is about pushing the virtual boundaries to bigger boundaries, breaking them, going as close as possible to physical. Your user context is now including the environment, which is super cool too. But it comes at the price of having to reuse your common things. Now it's more complicated. You have to figure out your building blocks, have a clear intent for your app, and maybe add some constraint like single floor or just a few rooms or whatever. In the current context, it's never been easier to make new things, but it's never been harder to be found. So I think it's increasingly important for your projects, your apps to be very creative, very different. And this is exactly the kind of stuff where we're at the frontier of what can be done. So have fun, explore, try to prototype very quickly, try new things. You're literally like being a pioneer by pushing the boundary of what can be made on spatial computing. And don't forget about the inclusive design. So people might have disabilities, they cannot walk. Well, that would be kind of a bummer for all these rooms, but think about like a smaller space, bigger space. How can we make sure your apps can scale for these different scenarios? And yeah, have fun. Thank you.
Thanks for sharing. It's really interesting. You mentioned one thing of feedback from the community, that just kind of problems you had. I'm just curious to hear more about what sort of feedback you had, like how often they use it, when do they use it, who uses it. Like, do you have any kind of user data of who your clients are and how they use it?
That's a good question. So a few things here. Personally, for my apps, I try not to do any telemetry, so there's no data being tracked whatsoever, which is probably not good practice, but I care about that. So instead, what I do is, I try to create some communities, Discord or X, whatever, and this kind of stuff you need to do, playtesting. You need to have people try your game. So Apple has this cool thing called test flights. You can basically do a demo, give a link to people to try. So the feedback came from people trying the test flight, giving me some feedback. And actually, in test flight, you can turn on an option to let people attach screenshots, give feedback directly in the app, which is super convenient. So that was kind of the process. And there's a lot of feedback I also got on Reddit. Reddit people are really cool on Vision Pro content because it's not too much. And so many DMs to answer. And I think if you actually engage with people, you get more and more of these, and people feel like you can be easily contacted. So it's like a virtual cycle. But yeah, a lot of feedback, where you have to kind of guess what's going to happen, because they might not respond either. It's like, oh, it doesn't work, it's stuck. But then, okay, why? So you have to kind of, really ask them some questions about what kind of space do you have? Without being too creepy, of course. But that was kind of my way. I just talk to people, get a Discord, and Reddit, X, all the social media, basically.
Awesome. Thank you.
Thank you. I have a question. I'm also a visual developer, but I'm more like a coder instead of an artist. So I wrote some shaders. It works, but it's not perfect, and it's not that amazing. Would you please give me some advice on how should I improve that kind of skill that can make very great shaders?
So is your question how to get better at shaders? Okay, yeah. Shaders are fun, but pretty difficult, mainly because you have to think a bit differently. GPU programming is not the same as programming for the CPU and whatnot. Personally, if you start, I would suggest to play with the graphs, like the shader graphs. So actually, Reality has one of them. You can play with it directly from Reality Composer Pro, I believe. So that's the easiest way, because you kind of have just a bunch of nodes. You can kind of quickly see the result, right? But the good news is, as much as there's so many languages like Metal, GLSL, Slang, Vulkan, whatever. It's the same principle. So if you pick one, even in the web, if you do WebGL, you can learn how to do shaders with whatever technology makes sense to you, and then just find people who do some cool stuff. For example, on ShaderToy, which is a pretty famous shader website where people showcase their skills. You can kind of learn from seeing people do things, ask questions. Again, Discord, so many people are more than happy to answer your questions. But the best way is to just get started. Try to do some simple stuff, do some gradients, do some, like think about like things you want to do, like maybe some water effect or smoke effect. And then small steps, it's not easy. But there's something pretty magical about, I mean, in my opinion, from like staring at a black screen with nothing going on to then seeing pixels everywhere. So I think, as frustrating as it can be sometimes, the reward function of like, okay, I'm getting there, I'm getting something is pretty cool. Something else I want to say before closing on that, debugging shader is difficult. When you do code, you can just put some printf, you can do some breakpoints, and now the tools are a bit better actually. If you do metal, you can actually put breakpoints as well. But in reality, it's not quite easy. So you have to be creative. So think about like, okay, maybe I can put a color for a given value, which is exactly what I showed earlier with, let's see, yeah, this. So this actually is, the color here is the normal of the mesh. So the normal is basically the surface, the vector that points up from the surface. So if you think about this as, the vector is three coordinates, right? So you can normalize that into 0 to 1, and then you can get a color. So the green corresponds to up, blue I guess this way. So this is one example of how you can debug, like data from a shader. So yeah, be creative on like, how to visualize the problem differently, and again, like anything, practice. Like try a bunch of stuff, don't be afraid, ask questions. There's no dumb question on the internet.
Thank you. Hi everyone. Thank you, Clem, for this great talk. And seeing your insights in this presentation, I think the biggest problem we have now with immersive content in mixed reality is occlusion. And I think it's a really difficult one. Not only furniture occlusion, but especially people and animals, What do you think is the roadmap to fix it? Is there any possible solution we can find in the midterm to avoid the pitfalls we can find with occlusion in mixed reality?
That's a very broad question. Yeah, I mean, I think it's kind of the fun part of this kind of technology because it's new. So there's not too many people, well, when something is new, people kind of like venture as a pioneer, right? So yeah, so it's kind of like everything is new, the tools are not there, the technology is not there, but it's part of the fun. And what I end up seeing is, communities of people finding each other, talking on Twitter or whatever, and then they share their sample code, and they share their findings. Oh, I found a bug here, I found a technique to do this. I don't have the video here, but there was someone who just for fun found a way to add a physics component to the UI, and the UI just falls down and breaks on the floor. It's really awesome. And no one would have thought about this until the guy was like, I'm just going to try it. So yeah, for like these kind of things, until it's mature, and I know XR has been there for a while, but yeah, I would say just, find communities and share what you work on. Don't be afraid of like bad stuff, whatever. Like there's no bad stuff. We're all trying things. So yeah, find the community, find the cool people, the cool projects, and again, like practice, and don't be afraid to try new things as well. That's it.
I just want to add one thing for Clem. The question to how to make great shaders, I think you should just mention a little bit more about what ShaderVision is.
Oh.
Explain that for somebody wanting to build shaders. This is a wonderful tool.
Oh, thank you. That's nice. Yeah, and ShaderVision was made just as a little fun app. You can actually do live shader editing in Metal. And there's a few samples actually. You were talking about like how to learn. Yeah, there's some samples. You can see how I did this stuff. But I think for most production, for games, whatever, it's going to be more like shader graphs, where it's a bit more high level, and the creatives kind of sort of do no-code solution. But yeah, it's one of the ways to learn shaders. So thank you for mentioning that.
Okay, thank you, Clem. Thank you for the deep dive into the design of the mixed reality experience. 混合现实的体验是非常复杂的。Clem 刚才的分享是充满了干货，有很多非常宝贵的经验，相信大家都很受启发。那么接下来的，让我们先掌声感谢Clem精彩的分享。